In this video, I'm going to find the general solution of the ODE y prime is equals to xy plus x plus y plus 1. Then look at the second problem. The derivative of y with respect to x is equals to 1 divided by x squared minus 1. Given the initial condition, y naught is equals to 0. So I'll start by looking at the first problem there. Given any first order ODE, we can solve the ODE using separation of variables, an integrating factor, or the method of solving exact ODEs, or the method of solving Bernoulli equations, that is if the equation is nonlinear. But I always prefer to use the method of separation of variables if it is possible to separate the variables there. But if you cannot separate the variables, then I'll use the other methods. So for this particular problem, I'll start by trying to separate the variables. To do that, I'll look at this part here. We have xy plus x. We have a common term there, the x, so we can factor that part, the x there. So when you factor that, we would have the derivative of y with respect to x is equals to x multiplied by y plus 1 plus y plus 1. I can now look at this part here. Let me now just put it in parentheses. And we would have the derivative of y with respect to x is equal to x multiplied by y plus 1 plus y plus 1. Now looking at this part here, what we are seeing there is we have a common term, y plus 1. So we can factor that common term, the y plus 1 there. And when you factor the y plus 1, we would have for the first part, when you are taking the y plus 1, it will be y plus 1 multiplied by x, then plus. The second part, when you factor the y plus 1, will remain with a 1. So we would have y plus 1 multiplied by x plus 1. Now when we have the equation in that form, we can separate the terms that have y and the terms that have the x. Write all terms with y on the left hand side, terms with x on the right hand side, then go on and integrate. So I will just separate the variables there, then go on and integrate on both sides. Now looking at the integral, which is on the left there, the integral of 1 divided by y plus 1 gives us ln of the absolute value of y plus 1. Then the integral on the right will give us x squared plus 2 plus x, then plus the constant of integration. So the result that we have there is ln of the absolute value of y plus 1 is equals to x squared divided by 2 plus x plus c, where that c is a constant. I'll go on and make y subject of the formula. Make y subject of the formula, we take exponents on both sides. So when you take exponents on both sides, on the left-hand side will remain with y plus 1. And to make the y the subject of the formula, when we have y plus 1, then we'll subtract minus 1 on both sides. So we would have the result there is y is equals to exponent of x squared divided by 2 plus x plus the constant c minus 1. So this part here that we are having, that's the general solution of the ODE that we are given. I can now move on to question number 2. The derivative of y with respect to x is equals to 1 divided by x squared minus 1. Given the initial condition, y naught is equals to 0. I can write all the terms with y on the left hand side, terms with x on the right hand side, then integrate. So when I do that, we would have the terms with y, would have dy, then 1 divided by x squared minus 1 dx, then integrate on both sides. Now looking at this part here, this x squared minus 1, what we see there is a difference of 2 squares. And we can write difference of 2 squares there, the x squared minus 1, it will be x minus 1 multiplied by x plus 1. So the denominator of the integral, which is on the right hand side, will become the integral of 1 divided by x minus 1 times x plus 1 with respect to x. Now to evaluate this integral here, what we need to do is we need to use partial fractions. So we use partial fractions to evaluate the right hand side there. So for this fraction there, the 1 divided by x minus 1 times x plus 1. Using partial fractions, we can write it as a divided by x minus 1 plus b divided by x plus 1. Put those terms under a common denominator, and then we would have a multiplied by x plus 1 plus b times x minus 1 divided by x minus 1 times x plus 1. But looking at the fraction that we started with them, and this fraction here, we are saying they are equal and they have the same denominator. So if the denominator is the same, that means the numerator is the same as well. So we equate the numerators of those two highlighted parts, and we have a multiplied by x plus 1 plus b times x minus 1 is equals to 1. Now to find the values of a and b, using this equation here, I'll try to eliminate a part which has a, then go in and eliminate the part which has b, then solve for the a and the b. So to eliminate the part where we have the a there, here we are having the part x plus 1. To eliminate that, we would need to put a 0 there. To have a 0 when you have x plus 1, we can set x equals to minus 1. So if we set x equals to minus 1, we would have minus 1 plus 1, which will give us a 0. Then we would have a times 0, so the a will be gone. And then we would have b multiplied by minus 1, minus 1. So it will be minus 2b is equals to 1. And you solve for the b, then we have b is equals to minus half. So for the first one, I eliminated the a there. I now go on to try to eliminate b. To eliminate the b, I look at this part here. We're having x minus 1. If we want to have a 0 there, we put x equals to 1, because we have 1 minus 1, which will give us a 0. Then look at this part there. If we put a 1 there, we would have 1 plus 1, which will give us a 2. So if we're saying x equals to 1, we would have 1 plus 1 is equals to 2. Then we would have 2a is equals to 1. And then solve for the a, we would have a is equals to a half. So we now have our a is a half, our b is a minus half. So for these values of the a and the b, we are going to substitute them here in this fraction there, a over x minus 1 plus b divided by x plus 1. And that will give us the right-hand side of the integral there. So our integral would then become the integral with respect to y is equals to 1 divided by 2 times x minus 1 minus 1 divided by 2 times x plus 1. So that's the equation that we are having now. And on that equation there, if we look at the left-hand side, the integral with respect to y, it will just give us a y. For the integral of 1 divided by 2 times x minus 1 with respect to x, it will give us a half multiplied by ln of x minus 1. And for the integral of 1 divided by 2x plus 1 with respect to x, it will give us a half multiplied by ln of the absolute value of x plus 1. So substitute those integrals that I've just highlighted, and the integral of with respect to y would have y is equals to half multiplied by ln of the absolute value of x minus 1 minus a half multiplied by ln of the absolute value of x plus 1 plus c, where c there is the constant of integration. But what we are given there, if you look at this part, we are having y naught is equals to 0. What that part is saying is when x is equals to 0, y is equals to 0. So we substitute when x equals to 0, y equals to 0 into this equation here. We are putting wherever we have y, we are putting 0. Wherever we have x, we are putting 0. We will have 0 is equals to a half multiplied by the ln of the absolute value of 0 minus 1 minus a half multiplied by the ln of 0 plus 1 plus the constant of integration, the c there. But looking at this part here, 0 minus 1, it gives us a minus 1. When you take the absolute value, it gives us a 1. ln of 1 will give us a 0. Then on this part, we just remain with ln of 1. ln of 1 is a 0. So we are having 0, 0 there, then plus the c. So what will remain with is c is equals to 0. So we are saying that c is equals to 0. And substitute that c equals to 0 on this part here, where we have the c. So our equation will become y is equals to a half multiplied by ln of the absolute value of x minus 1 minus a half multiplied by ln of the absolute value of x plus 1. So what we are having there is the solution of that first order ODE given that initial condition y naught is equals to 0.